mention as advantage as well as disadvantage. Belt drive advantage and disadvantage. Now, first advantage, if you are going to see, then obviously they are simple, okay, and they are economical. These belt drives, that is, it may be flat, V, or timing belt, okay, or grooved belt, multi-grooved belt. These are all simple and economical one. Okay, this thing also we are going to compare with chain drive as well as with the gear drive. These belt drives are simple and economical. Also, you might be knowing that have you heard about the Harley Davidson bike or the bikes which are more than 600 cc, the power or the capacity having more than 600 cc, up to 800 cc to 1000 cc. All these bikes. Out of that, I'm going to take example of only Harley Davidson. There are different bikes. Okay, Suzuki, Yamaha, all these bikes. In that case, instead of using belt drive, because in case of conventional two-wheelers, which we are using here, that is all the two-wheelers which we are using, they are using chain drive for transmitting the power. But for this high capacity two-wheelers, high power two-wheeler, you can say again, this belt drive is used for transmitting the power. Okay, instead of chain drive, because again they are simple in design and they transmit more power with high speed. That is what the limitation of chain drive is. Now next is parallel shafts are required. Okay, this can be considered as a disadvantage also, and we can use it for the advantage. Then this overload and jam protections are provided. That is nothing but in case of belt drive, if the machinery gets overloaded, then instead of getting failure in uh, any machinery part, any machinery part, the failure or the belt stops transmitting the power. That is nothing but it gets slipped, right? So yesterday only I have taken an example of this. So that that is again we can say as a advantage, because you know the costlier parts which may get failed in that machinery, that costlier parts will not be actually get failed instead of the this property of belt drive as it is going to get seen. Okay. The next, noise and vibrations are damped out. That is most important advantage of this belt drive, because as already earlier I have explained that it will act as a damper. Yesterday only we have completed BE project orals, in which one project was based on the reducing the vibration of injection molding machine. So in that case, instead of having gear drive, we have replaced it by means of belt drive, and we found that the vibration amplitude level gets reduced, and it happens because the belt drive is a vibration absorbing device. It will act as a vibration absorbing device instead of gear drives, because all other parameters are there based on which the vibration transmission is depend. Also, the amplitude of vibration that depends. But this is one of the major factors where the vibration absorption takes place. Okay, even sometimes uh, in the due period of the working of that machinery, that uh, shocks may be generated. And just a minute. Sorry for the interruption in between. So I was talking about the shocks which may be generated in the due application of that machinery. That shocks also get absorbed by means of this bale drive. Okay, and fluctuation that happens because of the fluctuation in load, definitely. The next advantage is that they are absolutely lubrication free, because if you are going to compare the bale drives, even rope drives, with the other type of drives, that is chain drive and gear drive, then the chain drive and gear drives, they require lubrication, frequent lubrication, and which comes under the maintenance also. So in case of gear, that gears are actually gearboxes are filled with the oil, lubricating oil, and they are deep into oil, and likewise lubrication is done for the gearbox or gears. Whereas in case of chain drive, we are going to continuously provide the lubrication for the chain drives. But in case of belt drive, okay, we are avoiding that lubrication. It should not come across with any lubricant oil, because it is totally depend upon the friction, because power is transmitted through the belt drive by means of friction, and we are making attempt to increase the friction, whereas lubrication reduces the friction. So they are absolutely free from lubrication, and they are highly efficient. Now here again, this is a comparative statement, which we can say if we are going to compare with some other drives, then they are highly efficient. Okay, not as in case of some other drives where slippage is more for transmitting the power, or wastage of power take place, like in case of even in chain drive or gear drive, some of the power get wasted in the friction, whereas in case of belt drive it get wasted because of the slip. But if you are going to compare it, then the percentage which get wasted, that is less in case of this belt drive. Then they are very economical when shafts are separated by a large distance. Obviously, if you are going to cover large distance with the help of suppose gear drive, then what you require? You require either a large gear or high number of gears. That is, you have to manufacture too many gears if you want to cover some distance, long distance. But this belt drive can give us that coverage of distance in a very easy way and in economical way, right? So these are overall advantages of this gear drive. Now, if we see the overall disadvantages, okay. Now, same point here I have written first, that is efficiency is less. Okay, that is again why, because it is because of the comparative statement. If you are going to compare with some drives which are transmitting more power and with less sleep, then we can say the efficiency is only up to 55 to 95%. Sometimes we are going to get it as a 98, 99% also. With that, if you are going to compare, then these belt drives are the not efficient. Okay, only 95% efficiency there. And second disadvantage is that designed to sleep when overload occurs. What it means? Actually, this statement we have written for the advantage also. That advantage, while you are writing or while you are explaining that statement in advantage, at that time we are going to give cost benefit of the rest of the equipments or all the parts of the machinery which may get break because of the overload, and they are more costlier, that gets avoided because of the sleep. But in some cases, some applications, if the sleep is more, with small overload, if it gets sleep, then we can say it is not that much economic. Average, that is, while we have seen this, we have taken example at last lecture, that when it gets overloaded, we have taken an example of that juice maker, right? Sugarcane juice maker. In that case, if it gets overloaded, then belt is going to slip over the pulley. But if it happens frequently because of the improper tension of the belt, because of the what weird out the belt, or because of some other reason, then that is not that much economic. Okay. Then they resist abrasion. That is where the abrasive type of environment is there. They cannot resist it. Okay. Then okay, this is one advantage. No lubrication is the advantage. Smooth running is advantage again. Okay, we are talking again advantages only. Okay, so this list can be again can be explained, and you can add two more in this list as the advantages of the belt drive. Then, if you are going to see the disadvantage, sorry, that previous thing which I have explained, that was advantages only. Now, if you see the disadvantages of belt drive, then the angular velocity ratio is not necessarily constant or equal to the ratio of pulley diameters because belt gets slip. Now, this is a mathematical term. What it means that angular ratio or angular velocity ratio, that is nothing but if you are going to uh, have the angular velocity of driver as omega 1 and angular velocity of driven as omega 2, then omega 1 divided by omega 2 is called as velocity ratio. And that velocity ratio is not remaining constant throughout the application because of the slip which occurs in the belt. Okay, and that is the disadvantage which doesn't happen in case of chain drive as well as in case of gear drive. Whatever may be the angular velocity ratio which we have designed, that will remain constant for the chain and gear drive. Then next disadvantage is that heat gets built up, that is temperature gets increased when we are going to increase the velocity of that belt, that is 35 meter per second. If this high velocity is transmitted by means of belt drive, then the heat gets occur. And you know why? Because this heat will get occur because of the slippage. And next thing is that all this power transmission is taking place because of the friction only. And slight, what we can say, slip in the pulley and belt at this high speed, you can imagine that what will be the speed, that is 35 meter per second. That means very huge speed it is. Okay, you can convert it into kilometers per hour, then you will come to know how much speed it is. Can you help me, anybody of you, to convert this into kilometer per second or kilometer per hour? 35 meter per second means how much kilometer per hour? Can anybody of you do a calculator? Just we want to convert this quantity, 35 meter per second, into kilometers per hour. Am I audible? Hello? Yes, sir, you are audible. Okay, okay. Then 35 meter per second. What do we have to do? 35 multiplied by 3600, right? It will become hour divided by 1000. So can you do this calculation? $35 multiplied by 3600 divided by 1000. It comes as a 1260 kilometer per hour. That is very huge speed. You know, if you compare it with the speed of our bike, car, train, whatever may be the things which we have experienced. If you compare this 1260 kilometer per hour speed, then you can imagine that is very huge speed. And in such cases, very small slip also may create large frictional loss. And this frictional loss means directly this friction is converted into heat, right? So huge amount of heat will be get generated. Now, power which we can transmit with the help of this belt drive, it is also limited. This can be again considered as a second disadvantage. Okay, that is 370 kilowatts. That is up to 500 horsepower. You can imagine this 500 horsepower because the engine which we are going to use for the tractor is of 100 horsepower. So it varies from 35 horsepower to 100 horsepower. So you can imagine that how much this 500 will be. It can become as advantage as well as you can write it in disadvantage also. Above which, if you want to transmit power, then we cannot go for belt drive. Then operating temperature is usually reduced to 31 to 185 degree Fahrenheit. That is minus 35 degree Celsius to 85 degree Celsius. This range is what we can say small range. And if we want to use or transmit power below minus 35 degrees Celsius, then we have to go for another type of transmitting device. It may be chain or it may be gear. Again, there are different challenges for transmitting power below 35 minus 35 degrees Celsius and above 85 degrees Celsius. If you want to transmit power, such type of environment may be there where you want to transmit power uh, where the temperature is above 85 degrees Celsius. Okay, then this belt drive cannot be used. Then some adjustment of center distance or use of idler pulley is required. Okay, for wear and stretch compensation. What it means? It means that to avoid wear as well as stretch of the belt, we need to have some idler pulleys, which will increase the cost and it can be considered as a disadvantage. Then a means of disassembly must be provided to install endless belts. Uh, you might have seen when we are going to uh, use new belt, particularly this statement is suited to V belt and multi-groove belt and timing belt. What it requires? It requires to disassemble pulleys and then only we can go for the replacement of the belts. That is not case in case of flat belts. Flat belts can be easily removed and can be installed without disassembly of the pulleys. But basically for the up to certain extent for the V belt also it is not required to disassemble that pulley. But for the uh, multi-groove belt and for timing belt, it is required to disassemble the pulleys and replace the belt. That can be considered under the disadvantage of the belt drives. Okay, up to this, do you have any question? Because this part we have completed. We are going actually for the selection of belts now. Do you have any question related to the part which we have covered from this unit? Hello? Can we go further? Jaydev, no doubt. Okay. Shall we move further then?
Yes, sir.
Okay, very good. Now here actually part starts, which is the core part of this unit actually. No doubt that the part which we have covered, that is also helpful for us. And if there is theoretical question, then we can easily answer with the help of that the part which we have covered. And this part which we are going to start, that part will be useful for solving problems based on this unit. And that is the selection of belts. Out of that, first we are going to cover selection of flat belt. Basically, you can call it as a design of flat belt drive. Now, design of flat belt means whether we are going to calculate the stress, strain, and whether we are going to calculate the dimensions. Because we know that when we are going to say the design word includes too many parameters. Out of that, if you are talking related to our syllabus, then it includes finding out the dimensions. And how you are going to find the dimensions? By means of the basic equations of stress. Now, the stress equation, whether it is necessary to derive some stress equations, or instead of the stress equations, can we go for the some standard method by means of which we can design flat belt drives. Later on, we are going to see design of V-belt drives also. That's why in bracket, I have written it as a selection, because we are not going to use any basic equation for the stress, but we are going to use some equations which are related to the other parameters like speed or power, okay, which you want to transmit, and the speed which you want to keep for the belts, as well as the angular speed of the two different pulleys which we want to join with the help of belts, and where you want to transmit the power. So all these other equations are used, but basic stress equation is not used to finding out the dimension. That's why instead of calling it, saying it as a design, we can say it as a selection. Okay. So selection of flat belt drives. Here this diagram, it is very simple diagram which involves two different pulleys where you want to transmit power. One is called as driving pulley. Normally diameter of the driving pulley is less. I'm saying normally because sometimes it may happen vice versa. But usually 98% you can say this diameter of the driving pulley is smaller than the diameter of driven pulley. And a reason behind it is that this power equation is 2 pi n t divided by 60, where n plays very vital role. If you want to say high speed, then the torque will get reduced. And as the torque will get reduced, that's why definitely you have to use smaller pulley. Whereas the power generation which is taking place in the power generating devices like IC engine or electrical motors or turbines, where these all power generating units are having somewhat higher speed, whereas that much speed may not be required for the application. So we can reduce that speed, and while reducing speed, the change in dimension of the pulleys take place. Okay, how that we are going to see in the next slide. So these are the two different pulleys, driving and driven pulley, and these are connected by means of a belt. And this power transmission takes place when driving pulley is going to rotate, and this belt is going to move without any slip on that pulley. Then it is transmitting power to the other pulley, where again is wounded on the pulley. This belt is wounded on the pulley, and at that place also the slip is not going to take place, and by means of that we are going to transmit the power. If the sleep is going to take place, then definitely we are not able to transmit any power. It will be wasted in the sleep only. Getting me? So we are assuming that the sleepless activity is taking place between this pulley and beds. A normal cross section which is used for the flat belt is this rectangular one, where this T is the thickness, we can say, of the belt, and B is the width of that belt, which may be vary according to the requirement. Okay, so this diagram indicates the flat belt drive. Next slide, when we are going to see, basically there are two different ways by means of which we can design this belt drive. What are that two different ways? The two different ways are nothing but first is designing flat belt drive using manufacturer's data. This is the one way by means of which we can design this drive, that is flat belt drive. And second is that designing flat belt drive using basic equations. What are that basic equations? As I was talking about the stress, that stress is the finding out the stress, that is the basic equation. Okay, and deriving that equation from the situation where you want to use this drive, as we have derived that equations in case of knuckle joint, then quarter joint. Also, we have derived that equations for other design process. Okay, whereas we have designed that levers. In that levers also we have used that basic equations which we have derived from the given condition. So these equations also can be derived, and the first way is that the designing of that belt drive from the manufacturer's data, that is manufacturer's catalog, the catalog which is available and which is provided by means of manufacturer of the belt drive. So amongst these two ways, the former, that is number one, method is simple and practically applicable too. Now it involves the uses of data provided by the flat belt manufacturers to solve a design problem. Means the problem statement which we may be facing, that problem statement with you can give a solution to that problem statement by means of that former uh, design procedure also, and that is first design procedure, that is nothing but designing flat belt drive using manufacturer's data or catalog. By means of this method also we can have the satisfactory solution for our design problem. Okay, now this is covered in this rest part of the unit and all the article. So we are going to see first method by means of which we can design the belt drives, flat belt drives, specifically talking. So we'll see. In order to design a flat belt drive using manufacturer's data, basically we have to go through some process, and that is again we are solving that problem step by step. And what are the that processes by means of which we can go for the designing of flat belt drive. Now hereafter I will not call as a design, I will call it as a selection. Okay, because it involves formulas, but it doesn't involve the basic formula of stress. That's why basically we are going to select the belt required belt drive from the manufacturer's catalog by using some basic or some equations. But we are not going to use the stress equation, which is very basic equation for the designing, for the finding out the dimensions. That equation as we are not going to use, that's why I will avoid to say as a designing of flat belt drives. I'll use word as a selection of belt drives. So what are that process by means of which we can go for the selection of the flat belt drive? No doubt that same process will be applicable for the V belts also. Okay, but formulas are modified somewhat, and the data which we are going to use, that data also is different from the flat belt drive. So we are going to repeat it for the V belts also. But normally, please go through this process, because sometimes in exam also they will ask question that what is the process or what are the steps which are involved in the selection of V belt or flat belt. Okay, so from that point of view, these steps are important. A first step is that we have to find out the pulley diameters. Now, these pulley diameters are actually selected from the standard dimensions of the pulleys, and that can be calculated by means of the data which will be provided for solving of the particular problem. Now, the typical statement of any problem which is related to the selection of flat belt or V belt is that for the application of industrial fan, we require to use a belt drive which will work under the condition of maximum 45 degrees Celsius. It will be vary from 25 degrees Celsius to 45 degrees Celsius, and the power or the source of power is used of 5 kilowatt. Okay, so these type of statements are there for our problem, and then afterwards we have to select such a pulleys, then belt, then we have to again decide the center distance. So in some that the statements, sorry for the interruption. As I was explaining that what are the steps which are involved in the selection of these belt drives. Out of that, first process is to find out the pulley dimensions, and it is required for the selection of the belt. And sometimes that data may be provided by the statement or the problem which you are going to solve, but it may not be a standard one, because in case of selection of belts, we require the standard diameters of the pulleys, because pulleys are also standard. As we are going to purchase this belt drive by means of number, I want for 5 number belt, 6 number belt, or yes 5 number belt. Likewise, we are going to ask for the for shopkeeper to have the belt. So what it means that 5 number belts, yes 5 number belt. Okay, it is a specific number which has been given for the particular belt, and dimensions as well as length as well as center distance is fixed for that particular belt. Likewise, we are going to select belt from manufacturer's catalog. And who is going to decide that number of belt? That is what the specific numbering which is given to the belt. That who is going to decide? These all steps are going to decide. So out of that, first step is that we have to find out the dimensions of the pulley. Normally, capital D is the diameter of bigger pulley, and small d is the diameter of smaller pulley. And in most of the applications, this capital D is for the driven pulley, and the small d is for the driver pulley, because in 90%, 98% applications, this driver pulley is having less diameter than the driven pulley. Next step is that we have to find out the speed of driving and driven pulleys. Now this driving and driven pulley speed, that is basically angular speed, which we are going to mention with the N1 and N2. This N1 is nothing but the RPM, revolutions per minute, of driving pulley, whereas N2 is the speed, angular speed of driven pulley, okay, which we are going to mention in RPM. Then third step is design power in kilowatt, that we are going to calculate the power which you want to transmit in kilowatt only. If it is given in the watt, then we have to convert it into kilowatt, no doubt. Okay. Or if it is given in some other unit, we have to convert it into kilowatt. Okay. Then fourth step is that we have to find out the velocity, linear velocity. Okay. I'll say it as a linear velocity. That is proper word. That linear velocity of the belt, that is in meter per second, as we have calculated in previous example, and it was 126, not to 1260. It was 126 kilometer per hour, and which was 35 meter per second. So this velocity we have to find out. Then afterwards we are going to select the belt. Okay, that particular number of numbering which has been given to the belt, that number we are going to select. Later on, we are going to find out how many plies are required. Plies means the layers which are required on that belt. Okay, because belts are manufactured by layer, and these are called as plies. So for the flat belt, we are going to calculate number of plies which are required. And next, we are going to calculate the load rating. Okay, that is what will be the capacity of that belt drive, which can be sustained by means of that belt drive. Then we are going to calculate width of that belt. Then based on that width of that belt, we have to select the width of pulley. And later on, that is last step, we are going to calculate length of that belt, flat belt, okay, which involves center distance between the pulley, diameters of the pulleys, okay. And these are the steps by means of which we can select flat belt from the manufacturer's catalog. Now, today we'll stop here. Rest of the part we'll see to the next lecture. If you have any question, any query, you are free to ask right